Hi, welcome back. We are on to acid precipitation. Today I'm coming to you from the Trenton area. If you've ever been back to Trenton Falls, it's technically illegal these days, but it's a really cool place to visit. You can fish along the edge of the water there, which is legal, and there's some really cool fossils. You can see behind me, there's a nautiloid right there. Trenton fossils actually are world-class fossils. There's fossils in little old New York that you don't see anywhere else in the world. People actually come here to study them from other parts of the world. Pretty neat, right? In your own backyard. Anyway, this particular type of rock will break down in an acid. We're not going to get into that. What we are going to get into is doing your acid precipitation lab. So let's go to your site and I will share my screen with you so you can see what we're looking at. I'm going to log into the master site. You're going to log into your course site. We're going to head over to laboratory and then we're going to scroll down to the acid precipitation lab. So the first thing you're going to do, of course, read the directions, but then watch these videos. So down here, there's a video and then there's the first activity correlates to the movie questions. That's going to give you the breakdown about acid rain, acid deposition, because it can be wet and dry. And so that's really step one. Make sure you have your litmus paper for this lab. This is a really fun lab. My kitchen was full of litmus paper when I was designing this. I had a blast. I hope you do too. Basically all we're doing is we're going to test household products and then you are going to buffer your acid rain using some common household items. But the one thing that must be ordered is that litmus paper. So that's got to come from Amazon, all right, or wherever you can get it. But again, the link is to Amazon in your materials file. So just make sure you have that. Okay. So watch a movie, answer your questions, and then when you move on to using the pH scale, you're going to read through the lab manual, the pages that cover this information, and you're going to answer these questions. But really quick, I'm going to give you a breakdown. Acids are any number from 0 to 6. Bases are any number from 8 to 14, and 7 is neutral. Now, the pH scale is very similar to the scale of the metric system because it's logarithmic, meaning it's a base 10. So every single time you jump from one number to the next on the pH scale, it increases or decreases acidity by a factor of 10. Now that's like 10 to the x. X is the factor, the x factor, all right? So it's exponential increase. A lot of times students make mistakes when they're answering these questions because they add their tens as opposed to multiply their tens, okay? For example, if I said that the pH changed from an 11 to a 9, the first thing we know is we actually increased in acidity. See how we headed towards the acids? The lower the number on the pH scale, the higher the acidity, okay? It's kind of inversely, it's kind of backwards the way you think about it. Everybody thinks, oh, the higher, it's a greater pH, it's a greater acidity. Opposite, lower pH, greater acidity, right? So when you get down here into like the ones and the halves and the quarters and all that, that's like super acidic stuff, like battery acid type, really acidic, burn your skin stuff, this lower stuff. You're going to have some fruit juices in the 2s and the 3s, which are, semi-acidic. Anyway, so back to our question, from 11 to 9, that's 2 jumps. 1 jump to 10, 2nd jump to 9, 1, 2, okay? A lot of times students will say, oh, well, that's 10 by 10. And they add. Don't add. 10 and 10 is 20. That's wrong. Your answers will always be whole value tens, okay? Zeros. So if I go from an 11 to a 9, it's a factor of 10, 2 jumps, 10 times 10. All right, so 10 times 10 is 100. That's the same thing as saying 10 to the 2. All right, so 10 squared is 10 times 10, which is 100. If I jump down to neutral, to 7, that's 1, 2, 3, 4 jumps, okay? 10 to the 4, and count it with me, all right? 11 to 10 is 10, to 9 is 100, to 8 is 1,000, to 7 is 10,000. And 10,000 has 4 zeros. 10 to the 4 is 10 times 10 times 10 times 10, 10,000. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. Okay, so just do your tens. Don't add those. That's the biggest mistake in this. Okay, then moving on. You are going to lime your lake. Now listen, there are some reflective questions in this, okay? When it says, you know, did your solution buffer? You can say yes, okay, or no if it didn't. But when it's asking you a reflective question, and this goes for every single lab in this lab, give me a few sentences. Give me something to go on. Don't just say, yeah, it was good, or no, it didn't. That's not really enough, okay? You're only gonna get partial credit for that. So if your eggshells or what am I trying to say? Your baking soda buffers, and it's the reflective part, not just by how much did it buffer. So, well, yeah, it buffered by this much. So it was a good buffer, it was a so-so buffer, it didn't buffer at all, it didn't do anything, it wasn't good. Give me a sentence. Again, if you're not gonna handle eggs, you can use the baking soda, but I prefer you to use the eggshells because it is the actual type of substance that is found in nature. It's similar. Calcite, calcium carbonate. So calcite is the mineral, which is made up of the molecules calcium carbon and oxygen, which the molecular name is calcium carbonate. So calcium carbon oxygen is calcium carbonate, makes the mineral calcite, makes the rock limestone that all of the environmental and gardening world refers to as lime. It's all the same stuff. It all buffers, it all reduces acidity. Okay, activity 4, again, you are going to, first we're gonna lime a lake, then we're gonna do our soil. So we're going to add a little bit of the crushed eggshells or, oh no, actually we're just using our soil. We're not adding anything. Follow the directions. You're gonna see if your soil buffers, see if your soil has any buffering properties. So this means you need to have your soil dry. That's one of the first things you need to do when you start this class is make sure you have your supplies and your soil. I've said that, so hopefully it's you have it ready. If not, you better hurry up and dry your soil. Put it in the oven at 200 for a couple hours, it'll dry out. Be careful using your oven if you choose to bake your soil. Okay, then last thing, okay? Testing your household product. You're literally gonna go around and dunk litmus paper into whatever you have kind of kicking around the house. I did bleach. I did, let's see, I did orange juice, maybe tea. I drink a lot of tea, so that was fun to see how acidic that was. People try different alcohols, which, if you're curious about that, go for it. Anything that you're curious about what the acidity is, do it. And try to make sure you get a range, okay? So if you're getting a lot of stuff and it's kind of like the same pH and you're getting like 3, 4, whatever, expand your horizons and use another product. Cleaning products, food products, you can do pickle juice, mayonnaise, it all, as long as it's wet, it's gonna change that litmus paper. You can do the water that comes out of your tap. Those of you who have water softeners, you should see a little something happening there. Sky's the limit on what you can test, and your packets come with a lot of litmus paper, so you don't have to keep it to the required, however many I ask you to do on this. When you are answering these questions about what the range of household products you have, you're going to go through and it's going to say, okay, well, what was your first product and what was its pH? So you just answer that. It was a pH of 4. It's enough, okay? But then later on, it's going to say, okay, what was your most acidic? And you're going to say, I don't know, maybe your most acidic was apple juice. Okay, you're going to say apple juice with a pH of. Make sure you put that pH of in there as like a reminder. Don't make me scroll back up to the top, find your apple juice, and remember, oh yeah, their apple juice was 4, okay? Then same for your highest pH, your most basic, okay? So if you did bleach and you get a 13, put that in there. My highest pH was bleach with a pH of 13. Don't make me go find it. It's a pain in the butt, okay? Then it wants to know what the difference in acidity is between your most acidic and your least acidic product. And this is specific to you and what you test, okay? So it's whatever you do, but tell me what that range is in its exponential factor of 10, okay? And that is it for the acid precipitation lab. I hope you have fun.